Hi everybody! So in today's video we're going to be starting to talk a little bit more formally about graphical limits. So how we look at limits when we are given a graph to examine. So let's start by just formally defining a limit. A limit of a function describes the y value, or in other words the value of f of x, of the function close to a particular value of x. It does not necessarily give the value of f of x or give the y value. It just describes what's happening close to that spot. So here's what we normally write. We normally write the limit, so we abbreviate that lim, as x approaches a. Whatever function we're examining goes here, equals L. Now here's what this really means. Here's what all these pieces are. This piece right here tells you what x value you are approaching. F of x is the function you're examining. And the answer to a limit, so this L, is the thing you're calculating. This is what you need to figure out. And it's always a y value on the graph. Now, what's really important to recognize here is that the actual value of the function, so where the closed circle is, does not affect the value of the limit. So for example, in this picture, you'll notice that there is an open circle, there's a hole in the graph when x is valued of c. So when the x value is c, there is no defined function value. It doesn't exist. There's a hole there. It doesn't exist. However, we would still say that the limit as x approaches c of this f of x function is equal to this y value. Because when x gets close to this number, the y values get close to this number. Even though they never actually achieve that value because there's an open circle there, it still gets close. All right, so there are different types of limits. There are what's called a right-sided limit, there's a left-sided limit, and there's a two-sided limit. So let's look at a right-sided limit first. A right-sided limit looks at the behavior of a function as x approaches the given value from the right. So we would write the limit as x approaches c, and we would put a little plus sign, meaning from the right, of f of x equals whatever your limit, your y value would be. In this, a particular example would be the limit as x approaches 2 from the right. So in other words, I want to get close to this x value from the right side, would be would be 8. Because when I approach from the right, I'm getting closer to this open circle, and the y value of that open circle is 8. Now we could also look at the left side limit. So the left side limit, we're going to do the same thing, only we're going to approach the given value from the left. So we would write the limit as x approaches C, and we would put a little minus sign to mean from the left, of f of x equals whatever your y value is, L. If we look at the same exact graph and we say, okay, well, what would the limit as x approaches 2 from the left be when I look at this graph? I would kind of do the same thing. I would approach the number 2, but from the other side. So I would come from the left side, and when I approach this value of 2 from the left, I'm approaching this closed circle. So the value of that y value at that closed circle would be 6. You'll notice there are 2 different answers for this problem depending on which side we are approaching from. Sometimes there are going to be 2 different answers, sometimes there will only be the same answer, but you have to look at both sides separately. Now, a two-sided limit looks at the behavior of the function as you move towards the given x value from both sides. We know we need to check both sides if we just see the limit as x approaches c with no plus or no minus. Now, this is only going to exist if the limit from the left is the same as the limit from the right. So, in other words, whenever it doesn't specify check the left or check the right, you have to check both and see if they match. In other words, a two-sided limit only exists if both one-sided limits approach the same number. For example, if I said, what is the limit as x approaches 1 of f of x? Because there's no plus and no minus here, you would know I need to check 2 things. The limit as x approaches 1 from the left, and also the limit as x approaches 1 from the right. Now, on this particular graph, as I approach 1 from the left, the value I'm approaching is this closed circle here, which has a value, a y value of 4. As I approach 1 from the right, the value I'm approaching is this open circle, which has a value of -2, a y value of -2. Because these 2 numbers do not match, we would say that this limit does not exist because those 2 values are not the same. So what we're going to do now is just practice looking at some graphs and getting some answers. So let's start with number 1. This says, tell me the limit as x approaches 1 from the right. So here's the number 1. I'm going to start to the right of there and slide towards the 1. When I do that, I'm getting closer to this open circle, which has a y value of 1. Then I'm going to check the value as x approaches 1 from the left. So to do that, I'm going to start to the left of 1 and slide towards 1. And then I'm approaching this same open circle, so the value would be 1 again. Next, I want to check the two-sided limit. So x approaches 1 means I need to check both sides. Now, lucky for me, I already checked those in problems 1 and 2. So because these were the same, it tells me that this answer is just 1. If these were different, then this does not exist. If I approach the value of 2 from the left, so here's the number 2. I'm going to come from the left towards the 2. I'm approaching that closed circle. The y value of that closed circle is 2. If I'm approaching 2 from the right, which is problem 5, I'm going to come towards the number 2 from the right-hand side, and the value of that open circle would be 3. And for problem number 6, where I'm being asked to check both sides because it does not specify the left or the right, I would look at the 3 and the 2, and I would know that these are different because I already checked the left and the right in problems 4 and 5. So because those are different, I would say that this one does not exist. Now in problem 7, it simply says check the limit as x approaches 3. A lot of students struggle with this question because when they look at the graph, there is no obvious closed or opened circle at 3. But all that means is that the graph is connected there. So if I approach the 3 from the left or from the right, both sides are approaching that place where it connects, which means the y value there is 1. Again, I needed to check both sides here because it's a two-sided limit. There's no plus and there's no minus. For the number 4, again, the graph is asking me to check, or the question is asking me to check both sides because there is no plus and there is no minus. So if I approach from the left and from the right, both of those arrows are pointed to the same spot, that open circle, and the y value of that open circle is 2. Because they're approaching the same spot, I end up having that is the answer. And if they were approaching different spots, like for the number 2, then I had does not exist. Now, sometimes we're going to look at graphs that have asymptotes, but we still analyze them with limits the same way. So if I'm approaching the number -2 from the left here, -2 from the left is going up, up, and away. So we would write positive infinity as the y value that we're approaching. If I'm approaching 1 from the right, so here's the number 1, I'm coming from the right. Again, I'm going up, up, and away towards positive infinity. I'm looking at the y value that I'm approaching. The number 5, I need to check both sides because it does not specify if I'm checking the left or the right. So for the number 5, the left side goes down towards negative infinity, and the right side goes up towards positive infinity. Because those are not the same, I would write does not exist here. Limit as x approaches infinity. X approaches infinity means that x is getting very big. So in other words, I'm going sort of sideways on the graph this way very far. So this is 8. I want to go to 9, 10, 11, 12, 13, 14, 15, all the way up to infinity. Because of the way the graph is flattening out here, it seems to me that as I go farther to the right, I'm going to end up approaching 0 as a horizontal asymptote. And finally, as x approaches 0, I'm going to have to check both sides. So if I check 0, 0 is nice and connected, so both the left side and the right side are approaching the same value, which appears to be approximately -1/2. Again, a lot of students struggle with that because there is no obvious dot, but that just means it's nice and connected. Finally, the last thing we want you to be able to do is to be able to visualize a graph based on some limits that you're provided with. So here we're given 2 limits, and we need to sketch 2 possible pictures that could have generated those limits. So I'm going to start by just drawing a graph because I want to have something to kind of start with. So I'm just going to draw a y-axis and an x-axis. Now, based on these limits, the important x value that I'm going to be caring about is the 3. I'm going to be looking at what happens when I get close to 3, both from the left and from the right. So on the x-axis, I'm going to make sure that I label the number 3. It also looks like the important y values that I'm going to care about, there are 2 different numbers, are the 5 and the -1. So I'm going to make sure that on this graph, my y-axis goes up to 5 and down to -1. Once I've kind of got that framework set up, now what I'm going to do is try to figure out what's happening. It looks like from the left side, so if I start over here and slide towards 3, I'm approaching the number 5. So I'm going to put an open circle there. It also looks like if I start on the right side and I approach the number 3, I'm approaching -1, which means down here. I'm going to put an open circle there. Now, in order to approach that number from the left, what I'm going to need to do is make sure my graph starts over here and connects to the 5. And I'm going to need to make sure that my graph starts over here and connects to the -1 in order to make sure I'm approaching that number from the right. Now, you might be wondering, how does she know to make it look exactly like this? And the answer is, I don't. There are lots of different graphs that I could draw here. For example, I could draw a very similar graph that looks a little bit different, but there are a few key features that are going to have to be the same. One of the things that has to be the same is that I care about what happens close to the number where x is 3, and that there are 2 specific y values that I need to be really conscious of, the 5 and the -1. Now I'm going to once again fill in my open circle here and my open circle here. But now I'm going to make a different choice for how to connect this. Starting from this side, I'm going to make a crazy graph that goes like this, but that still connects to this open circle, because from the left, I have to connect to the 5. Then on this side, I'm going to make a crazy graph that goes like this, but that still connects to this open circle, because I still need to approach the -1. Now, you might also be wondering, do these have to be open circles? And the answer is no. We could fill in one of the circles. For example, I could fill this in and actually make it a closed circle, but I would not be allowed to fill in the bottom one as well. And the reason I can't fill in both is because then it would not be a function. It would not pass the vertical line test anymore. So I could fill in one or the other, but I could not fill in both. All right, thank you guys so much for watching. I really appreciate it. Have a great afternoon, and that's it.